Good morning, students. In the last class, we discussed about vector addition using triangular law and parallelogram law. And we studied by using these two laws, we can find the resultant of two vectors when they are connected in parallel. Now, if two vectors are in different direction, we learned the resultant as r is equal to root of a square plus b square plus 2ab cos theta, and direction is given by b sin theta by a plus b cos theta. So, we studied these two derivations, we studied these two equations. Now, in today's class, we are going to discuss it analytically. That means we are going to discuss it mathematically, how to obtain the resultant of two vectors, how to obtain the formula for the resultant of two vectors. So, for that here I am going to use parallelogram law. Please look at the board. Suppose this is vector A. This is vector A, and I am drawing another vector which is vector B. The angle between two vectors A and B is marked as theta. I am going to use parallelogram law to find the resultant. So, I made the parallelogram, and the diagonal of the parallelogram gives the resultant. So, this is the resultant vector. Now, I am extending two more dots to make a right angle triangle here. So, here also I made a right angle triangle. Now, let us see, I give the numbers as O, P, Q, R, S. The angle between the resultant vector and first vector is named as alpha. Angle between vector A and vector B is theta. Now, if angle between vector A and vector B is theta, then this angle will also be theta. This angle is also theta because both of them are corresponding angles. Similarly, if OP is B, then SQ is also B. If OP is B, SQ is also B because those are the corresponding sides of a parallelogram. So, I will write here as B, and this is our resultant. Resultant is written as R. Now, look at this triangle. First, I am going to take triangle QSR. In triangle QSR, what is sin theta? We know sin theta is equal to opposite side by hypotenuse. So, opposite side is QR by hypotenuse B. So, QR is equal to B sin theta. Let this be equation 1. From the same triangle, what is cos theta? Cos theta is equal to adjacent side by hypotenuse. So SR by B. So from here SR is equal to B cos theta. Let this be equation 2. So I got two equations. Now I am going to take another triangle, that is triangle QOR. In triangle QOR, you can say hypotenuse square is equal to base square plus altitude square. So here hypotenuse is OQ. So I write OQ square is equal to OR square plus QR square. Now can you say what is OQ? Yes, OQ is resultant R. So I will be writing R square is equal to OR can be written as OS plus SR. OS plus SR plus QR whole square. Now R square is equal to OS. Look at the figure. What is OS? It is A. So I write A plus SR. SR is written here in equation 2. SR is B cos theta. So A plus B cos theta whole square plus QR. Look at equation 1. QR is B sin theta. So I write B sin theta whole square. Now we will open the bracket. So R square is equal to A square plus 2AB cos theta plus B square cos square theta. So this part is expanded. Now here B sin theta whole square can be written as B square sin square theta. Now I write like this: R square is equal to A square plus 2AB cos theta plus I take B square common from these two terms. I will be getting cos square theta plus sin square theta. We have studied in class 10 cos square theta plus sin square theta equal to 1. So this will become 1 and you will get B square only. So I rearrange this and I will get R square is equal to A square plus B square plus 2AB cos theta. So from here what is R? R can be written as root of A square plus B square plus 2AB cos theta. This is the equation for the magnitude of resultant. So this is how we got the equation R is equal to root of A square plus B square plus 2AB cos theta. Now, so this is the magnitude only. So I write here as magnitude. Now how will we find the direction of the resultant? That is what we are going to study next. Direction is given by tan alpha. Let us go to the previous figure. In this figure, you take the same triangle QOR. In triangle QOR, what is tan alpha? Opposite side by adjacent side. That means QR by OR. So tan alpha is QR by OR, and OR can be written as OS plus SR. Okay, so I am going to write that now. Tan alpha is equal to QR by OR and QR is written like this, OR is written as OS plus SR. And we studied two things in the beginning itself, that means in equation 1 and 2, QR is B sin theta and SR is B cos theta. So I am putting these two things here. So what will happen? Look. Tan alpha is equal to QR is B sin theta and OS is A, that is from the parallelogram itself, OS is A and SR is B cos theta. So tan alpha is equal to B sin theta divided by A plus B cos theta. So from here I can find alpha. Alpha is equal to tan inverse of B sin theta by A plus B cos theta. So this is how we will find the direction. See, what is meant by tan inverse? I will tell you. The tan, when we say tan inverse, sine inverse and all, it is not actually the reciprocal. This is a representation which is called inverse trigonometric function. For example, what is the value of tan 45? 1. So tan 45 degree, you get the answer as 1. So if I ask you tan inverse of 1, the angle will be 45. So if the angle is given, you will get the value. If I give the value, you will get the angle. So that is what is called inverse trigonometric function. It is not the reciprocal. Similarly, sine 30. Sine 30 is 1 by 2. Or I can say 0.5. So if I ask you what is sine inverse of 0.5, you will say the answer as 30 degree. So this is called inverse trigonometric function. This is the way to find the angle in the vectors. Okay, it's just an example. So we got two equations. The first one is for the resultant, which is r is equal to root of a square plus b square plus 2ab cos theta, and second one is alpha, tan, which is tan inverse of b sin theta by a plus b cos theta. Now if two vectors are perpendicular, what is theta? 90 degree. Yes. So let us see. I am just going to give a special case. If two vectors are perpendicular, then theta is equal to 90 degree. So I will first write, let me draw the figure first. So two vectors will be like this, and if I put the dotted lines to make the parallelogram, it will come like this. and the diagonal will give the resultant. So this is how the figure looks like. This is vector A, this is vector B, and this is the resultant vector. This angle is 90 degree, and the angle between first vector and the resultant vector, this angle is alpha. Okay, this will be the figure if two vectors are perpendicular. So let us see how to find the resultant. How to find the resultant? Resultant is equal to root of a square plus b square plus 2ab cos 90. And do you know what is cos 90? Cos 90 is equal to 0. Therefore, 0 into this term, this entire term will become 0. So this term cancels and you will get the remaining answer as r is equal to root of a square plus b square. So if two vectors are perpendicular, you need to use only this equation. Got it? Now how will I find the direction? Direction is given by tan alpha. So tan alpha is equal to b sin 90 by a plus b cos 90. So here we have written cos 90 is equal to 0. So what is sin 90? Sin 90 is equal to 1. So we have those two factors. So I will put it over here. I will be getting the answer as tan alpha is equal to b sin 90 is 1 and cos 90 is 0. So I will get b by a. So tan alpha is equal to b by a, because cos 90 is 0, this entire term cancels out. So from here alpha is equal to tan inverse of b by a. So if two vectors are perpendicular, you can find the resultant as r is equal to root of a square plus b square, and the direction as alpha is equal to tan inverse of b by a. Okay. Thank you.